What is the physics behind thermoluminescence dating? Imagine a tiny crystal in ancient pottery or a burnt flint tool. Over thousands of years, it quietly collects invisible energy from the environment. This is the essence of thermoluminescence dating. Now, how does this process work? Let's break it down into simple steps. Certain minerals like quartz and feldspar have a special structure. When these minerals are exposed to natural radiation from radioactive elements in the soil or the material itself, electrons within the crystal get knocked loose from their usual positions. These free electrons don't just wander off. Instead, they get trapped in tiny defects or trap states inside the crystal's structure. Over time, as more radiation hits, more electrons get trapped, creating a kind of energy record of the radiation dose the mineral has absorbed. When scientists want to find out how old the sample is, they heat it up to very high temperatures, usually above 450 degrees Celsius. This heating gives the trapped electrons enough energy to escape their traps. As they do, they jump back into their original positions in the crystal lattice. When this happens, the energy they releases appears as a flash of light called thermoluminescence. The brighter this glow, the more trapped electrons there are, which means the mineral has absorbed more radiation over time. By measuring the amount of light emitted, scientists can figure out the total radiation dose the mineral has stored since it was last heated or exposed to sunlight. They then estimate how much radiation the environment around the sample contributes each year. Dividing the total stored radiation by the annual dose gives an estimate of how long ago the mineral was last heated or exposed to sunlight. This makes thermoluminescence dating especially useful for dating ancient ceramics, burnt stones, and sediments that have been heated or exposed to sunlight. The method can date objects from a few hundred years old up to several 100,000 years old. It's particularly helpful when radiocarbon dating isn't possible, such as with inorganic materials or very old artifacts. So, the physics behind this technique is all about trapped electrons and their releases as light when heated. This process allows archaeologists to piece together the timeline of ancient human activity and environmental changes.